So let's see what is a Kaggle competition. So in Kaggle competition, I have given you the training data set. I think training data set is quite clear. In this training data set, you have the number of proteins. Then this part is basically your protein ID. And after comma, that's basically amino acid sequence. So as I told you earlier also and described here also, that if it is in capital letter, then we call it non-interacting residue. If it is a small letter like this one, this is called interacting residue. I have already described in my lecture earlier that how you can create the different type of patterns and how you can do the predictions. The confusion starts from test file actually. In test file, I have defined like this, the residue number. Why I give this residue number? Because when you are evaluating on the Kaggle, it's not practically possible to give your data in this form and then evaluate it actually. So this is the limitations of Kaggle, that in Kaggle, we have to provide the residue number and then we have to predict for the particular residue, whether it's interacting or non-interacting. Here is the residue number 1001, 10,001, 10,002, blah, blah, blah. And same way, we have the sample ID 1001, 1002, 1003. So corresponding to that, we have to do the prediction. These are the random predictions I have put it here, but you have to put the real predictions. So from test file, you have to predict for these residues whether they are interacting or non-interacting. If it is interacting, we have to put value +1. If it is non-interacting, we have to put value -1. Am I right? So now I will show you in a better way that how you can handle it actually. Okay. So now take this slide. This is my sample file, and you have to write the values here +1, -1, depending on the values of this amino acid sequence. So test file, you can consider this is a single file which contain single protein which contain all these amino acids. All right. So let's say think about this part, this one. So I have put it like that, test1.txt, comma, A, this A is corresponding to this, then A corresponding to this, SSL, SSL, DEL, DEL. So whatever the residues are here, you have to just keep them in a sequence. So now it become a single protein which have the large number of amino acids, right? So now this is a one protein, and we can write this protein like this actually. So this is the sequence of my protein, test protein, right? Now let's say if I want to generate the pattern of length 7, then I have to add the both sides, 7 minus 1 divided by 2, and then it means 3x this side and 3x this side. I have not kept the whole sequence here, so ultimately you have to add the 3x actually. Okay, then you can generate the pattern like XXASS. So we have to generate the pattern for this A first. So I have to put the 3x are here, and then I have to keep this amino acid here, and then I have to take 3 more residues from this side, and these 3 residues are here, right? Similarly, go for the next, this one. So it will be shifted once. So instead of 3x, it will remain the 2x, because, sorry for this, this is basically, I will change it. This is a bold basically. And because we are predicting for this residue, and this is not bold. So then again, okay. Now, this time for the second residue. So second residue is bold. So we have taken 3 residues this side, 3 residues this side. So this is the another pattern. So this way you can get the patterns for your test sequence. Based on the model you developed in training data set, you have to predict for each pattern whether they are interacting or non-interacting. Let's say if this pattern is interactive, then you have to put +1 because it's ATP interacting. If it is again, so it means if this pattern is positive, means interacting, it means this residue is in ATP interacting. Okay, here again same thing, this residue is also in ATP interacting, we have put the +1. So this +1 value will go here actually. So we will replace this value in the sample text by +1. Okay, then this value, let's say if this pattern had been predicted non-interacting, so corresponding to that center residue S will be non-interacting. So this residue will go corresponding to this S, right? So it will reach here. So same way for the next S, you have to take this residue and predict it whether interacting or non-interacting. If it is interacting, put +1. If it is non-interacting, put the -1. So this way you can do the prediction of your sequence, and you have to put your values. You have to replace these values accordingly based on these values. Okay, so this way you can do the prediction for your test file. Okay, so that's all from my side. Now I will take your questions. Okay, now you can put your questions. You may put your questions in chat board. If there is no question, then I will stop my presentation. Okay. First question